Welcome to the video for mole calculations. So we're going to look at some exam questions here. Now there's two methods you can use. You can use the ratio method, which I think is the simplest method, or you can use the moles method. So we're going to do two questions both ways. So the ratio method, we don't need to know any formula. All we're going to do is look at the ratios of the relative formula masses in the question. So what I need to do here is work out, including the number in front of it, the relative formula mass of each chemical involved. So we want to calculate the mass of sodium hydroxide, which is this one, needed to make sodium sulfate, which is this one. So I can ignore the water and I can ignore the sulfuric acid. So I've got 2 in front of that, which means I've got 2 sodium hydroxides. So I need to calculate the sum of the relative formula mass. So sodium, if I look in the periodic table, there's 2 numbers. Remember, for the relative atomic mass, we're looking at the biggest number, which is 23 for sodium, 16 for oxygen, and 1 for hydrogen. So if I do that, that works out as 2 times 40, which is 80. And if I do the same for sodium sulfate, that's 2, because this little number 2 here means 2 sodium, so that's 2 lots of 23 plus 1 sulfur, which is 32.1, plus 4 lots of oxygen, which is 16. If I add all of those together, that gives me 142. So what this means is that 80 grams of sodium hydroxide gives me 142 grams of sodium sulfate. And what I want to know is how much sodium hydroxide I need to make 30 grams of sodium sulfate. So if I want to make 1 gram of sodium sulfate, so we're just going to use ratios to work this out. So I know how much sodium hydroxide makes 142 grams. So to make 1 gram, I would divide 142 by 142 to get 1. And what I do to one side, I've got to do to the other. So I'm also going to divide the left-hand side by that. So that will give me 80 divided by 142 grams. But what I actually want to know is how much is going to make 30 grams. So to get from 1 to 30, we times by 30. So then I need to times this side by 30 as well, and that's going to give me 80 over 142 times by 30. And if I stick that into my calculator, that gives me 16.9 grams. So that means that 16.9 grams is going to give me 30 grams of sodium sulfate. So that is my answer. So let's do a second example here. So again, it's giving me the chemical equation. So methane burns in oxygen to form carbon dioxide and water. Calculate the amount of carbon dioxide, so that's that one, made when 6.4 grams of methane is burnt. So again, I can ignore the oxygen and I can ignore the water. So let's just write these out here because there's a bit more space. So from that chemical equation, 1 methane makes 1 carbon dioxide. So I'm going to burn 6.4 grams of methane and I want to work out how much carbon dioxide that's going to make. So again, I need to look at the relative formula mass. So carbon, if you look in the periodic table, biggest number is 12. Hydrogen's 1 and there's 4 of them. And again on this side, carbon's 12. Oxygen, there's 2 oxygens and each one's 16. So that's going to be 12 plus 32, which is going to be 44. So what this means is that 12 plus 4 equals 16. So 16 grams is going to give me, so 16 grams of methane will give me 44 grams of carbon dioxide. So using ratios again, 1 gram of methane. So I've divided by 16 to get that. So I also need to divide by 16 on this side. So that's going to give me 44 over 16 grams of carbon dioxide. But I want to know how much I get if I burn 6.4 grams. So to get from 1 gram to 6.4 grams, I times by 6.4. So let's do the same to the right hand side. That gives me 6.4 times 44 over 16. If you add that, stick that into your calculator, you will get 17.6 grams, which happily is one of these. So my answer would be D. So that's the ratio method. We can do it's by the moles method. Now, I think this is slightly more difficult because you've got to remember a formula. So to do this, we need to remember the formula. Number of moles equals mass over molar mass. And that molar mass is either relative atomic mass if it's an element or relative formula mass if it's a compound. So whenever I'm doing these, I draw a little table. So I want to calculate the mass of sodium hydroxide. So I'm going to write that at the top of that column. And then the other chemical I'm interested in is sodium sulfate. So I'm going to write that formula in. And then here in this equation, there's three terms. So there's N, which is the number of moles. There's the mass, and then there's my relative formula mass. So I'm going to write in what I've got from the question. So I want to make 30 grams of sodium sulfate, so that I know the mass there, and I can work out the relative formula mass of sodium hydroxide and sodium sulfate. Now, we did this in the ratio method, so I'm just going to write these in because we've already done it. So sodium hydroxide is 40. Sodium sulfate we did previously was 142. So now if I look at this table, I'll see that I've got two quantities for one of them, so I can work out this missing number of moles. So number of moles is mass over relative formula mass. So that's going to be, the mass is 30 over 142. Now if we look in the equation, 2 sodium hydroxides give me 1 sodium sulfate. So if I've got 1 mole of sodium sulfate, I'm going to have 1 over 2 moles. Sorry, no, I'm not. So 1 mole of sodium sulfate gives me, has to react with 2 moles of sodium hydroxide. So however much sodium sulfate I've got, I need to times that by 2 to work out the moles of sodium hydroxide. So my moles of sodium hydroxide is going to be 2 times by 30 over 142. And if I stick that into my calculator, that's going to give me 0.42. So now I've got both the number of moles and the relative formula mass. So if I rearrange this equation, mass equals number of moles times by relative formula mass. So that's going to be my 0.42 times by 40. And if I stick that into my calculator, I get 16.9. So my mass of sodium hydroxide is 16.9 grams, which happily is what we got with the ratio method. So let's do this again for the second one here. So again, I'm going to draw my little table. So the chemicals I'm interested in are the carbon dioxide and the methane. So I draw my little table. I'm going to put methane there, carbon dioxide there, number of moles, mass, relative formula mass. And again, we worked out the relative formula mass in the previous question, so I'm just going to write that in. If you can't remember, go back and look at the start of the video. So I'm going to write in the mass from the question, which is 6.4 grams of methane. And now I want, if I look at that table, I can see I've got 2 values. So whichever one I've got 2 values for, I can work out the third value. So number of moles is mass over relative formula mass. So the number of moles of methane is 6.4 divided by 16. And if I stick that into my calculator, I get 0.4. Now, if I look at the equation, this one's a bit easier because 1 mole of methane gives me 1 mole of carbon dioxide. So however many moles of methane I've got the same of carbon dioxide. And now I've got my number of moles, my relative formula mass, so I can work out my mass is the number of moles times by the relative formula mass. So that's going to be 0.4 times by 0.4. And if I stick that into my calculator, I get 17.6 grams, which again is answer D. Okay, thank you for listening. See you next time.